Hi guys, good afternoon. I'm Aditya. Quick background about myself. I studied at PS University here in Bangalore. I did a short research stint at Purdue. Worked in many spaces, including ad tech, at Dobby Ads, health tech at Dozy, automotive at Bosch, and autonomous vehicles at Minus Zero. And now I'm building CopperPilot. At PS University, I was the Formula student EV team's electrical lead. Learned a lot of PCB design over there, a lot of schematic design, and a big steep learning curve, right? And yeah, at Purdue, I worked on autonomous driving cars. So picked up a lot of foundational AI over there, like how you gather data, observability and stuff, and, writing research papers. And, when I moved to Minus Zero, it was a lot of similar work and it was really fun, discovering fine tuning of these foundation models for like robotics. This kind of led me to think, right? Hey, if I want to train a model, right, or if I want to build a website or an app, I can go to Lovable or Cursor or Emergent, right? But say I want to build a PCB, right? Because I've had thoughts of building a hardware startup, and like it always comes to me. I'm like, oh, it's so tough to figure out how to build a PCB if you're not like a core electrical engineer. So just I wanted to get a show of hands to get an idea of the audience. Like how many people here have touched a schematic, say touched a breadboard, done anything in hardware? Please, a show of hands, please. Oh wow. Oh, okay. I did not expect that. Like that's a crazy distribution here. So to solve this pain point, like I'm looking to build CopperPilot. So I did a survey to find out what are the big pain points, right? Like so, a quick run through. Hours of reading data sheets, carefully selecting your components, tediously wiring up schematics, right? Schematic review with your team because you can make a mistake and you need to do multiple rounds of review to make sure you've not missed anything. And then PCB layouting, understanding your manufacturer's constraints, and fundamentally trying to catch mistakes before they happen. Because God knows we've sent a PCB to manufacture and get it back after a week or two to realize we missed one copper trace that renders the entire board, unusable. You can just move these things around, and you kind of realize most of these are solvable with LLMs, right? And Claude specifically. So you know uh, Hours of reading through data sheets and catching these mistakes before fabrication. LLMs can make short work of ingesting large documents and reading through them, and you turn it into an agentic workflow. It can iterate and study designs for minutes, hours even, right? So that helps with careful component selection and schematic review, right? And if you build like strategically designed tool calls, your agent can even read and write to the schematic, search through the web to find things that you a component that you might want to add to your schematic. So yeah, these were the things that came to mind, and this is what I ended up building. So a quick demo here. Um, so I saw this, FPV RC car that was built on top of an ESP32, and I was like, oh, cool! I want to build this. It has a camera, it has an ESP32, has a battery, a motor controller. So I just copy pasted the image into CopperPilot, and I described what I wanted to build. I wanted to use an ESP32. It needs to be an FPV car. I want the ESP32 to stream video back to me. We'll have an H bridge to drive the two motors in tank controls mode. And I was like, hey, cool, let's ideate about this. So then CopperPilot thinks about the idea, goes through it, and then it produces a list of components that we could use. And it also gives us a short block diagram, like a rough outline of how we could, wire everything up. Right. And so now I think I'm like happy with the components it's selected. I'm like, hey, cool, let's place these into the schematic. And I also mentioned, hey, I've already selected my ESP32, so just give me the other things, the power supply and the motor driver. And I also asked it, hey, place connectors to, so I can connect things to the board. So it goes, searches for the components, makes a couple of mistakes, but places everything in the end. And it gives us a diff. Like, hey, cool, this is what this is what I've added. Is this cool with you? And I'm happy with it. I hit accept. Right, and all of this gets placed into KiCad, and I just rearrange and rename things as per my liking, and place things as I'd like them. Now let's wire up the power supply. This AMS takes 5 volts in, gives 3.3 volts out. Let's wire it up to make sure all our components are powered, right? So I paste in the data sheet, and then it's able to read the data sheet, figure out, okay, cool, this is how we're supposed to wire it up. Uses net labels, gets it done. And now let's go get to the main thing. Let's wire up the entire schematic. First, let's come up with a plan. of how we want to wire things up, right? It gives me a rough idea of a plan, and then I said, cool, like let's go ahead and wire everything up. So it goes through each pin, makes the connection, and it comes back with a final diff, and that's very cool because it just wired everything up after reading the data sheets. And so I can hit accept, and I just take a closer look, and I see that, oh, cool, it's wired up the motor controller and whatnot. Let's just run an analysis to make sure we've done it correctly, right? I just paste the data sheet back in. I'm like, hey, let's do a component analysis. And now it finds out okay, look, it looks like motor power 2 and motor power 3 seem to be dangling, are floating pins. Are you sure? Is that what you intended to do? So VM2, VM3, maybe we need to look deeper into that, right? And if it is an issue, we should look into it. And it looks like the other pins seem to have been wired up quite well. And, once I'm done with the review, if I'm happy with everything, I can just move forward with this design and convert it to a PCB. At this stage, you can either auto route or manually route using existing tools. And yeah, like once you've wired everything up and you've designed your board layouting, you can go ahead and send it out for manufacturing. And that's how this accelerates your entire PCB design workflow. Bring down your number of iterations, and the time to complete each iteration also comes down because moving faster. uh, Lovable for like hardware. So how did I build this, right? Like, so um very simple thing. The input space is like an input schematic and a user request. And I want to give Claude the ability to, read the schematic and write to the schematic and maybe search the internet for components, right? And, I also discovered that giving a to-do list helps with smaller models, right? Like giving it a to-do list where it can write to the to-do list and validate that it's done really helps. And then finally, I have an output format validation to make sure the schematic is actually still in one piece. And yeah, I just use LangChain to hold everything together, and it works quite well. And so yeah, like CopperPilot is live, right? So if anyone's interested, do sign up and like reach out to me. Would be happy to chat if you guys have any hardware ideas you're looking to build. Yeah, thank you. That's it for me.